Welcome to today's class. In today's class, we continue at step number 2. In our previous class, we are dealing with how to write the correct Lewis structure of a molecule or a ion. We talked about the first step, which is determining the magic number. Today, we will start with the second step, which is determining the central or parent element in the molecule or ion. There are two basic rules in determining the parent element of a molecule or ion. The first rule is that only elements that obey the octet rule can be a parent element. That is hydrogen and helium, which obey the duplet structure, cannot be a parent element. Hydrogen and helium cannot be a parent element because they obey the duplet structure. That is, their outermost shell contain a maximum of 2 electrons. So that's the first step. The second rule is the first element in any molecule or ion is the parent element because it is always the most electropositive element. So let's look at, for example, if I have carbon 4 oxide, now the parent element is the first element, which is the element that obey the octet rule and the most electropositive element. If I have water, now we have said that hydrogen cannot be a parent element. So the parent element is what? Oxygen. If I have sulfur 4 oxide, the parent element is sulfur. If we consider thionite chloride, the parent element is also what? Sulfur. If we consider ammonia, the parent element is what? Nitrogen. If we have Cn minus, the parent element is carbon. If we have permanganate ion, the parent element is manganese. So, two rules to determine the parent element. Number one, hydrogen and helium cannot be a parent element. Number two, the parent element is the first element in any molecule beside hydrogen and helium. Number three, the parent element is the most fewest in number. Number four, the parent element is the most electropositive element. So that is how we determine the parent element. Step number 3 is distribute the other element around the central element. Let's take, for example, phosphine. Now, hydrogen cannot be what? A parent element. The parent element is what? Is phosphorus. So how do we do that? So if phosphorus is the parent element, the other element is what? Hydrogen. So let's distribute. We have phosphorus, the parent element. We distribute the hydrogen around the parent element. If we have carbon disulfide, carbon 4 sulfide, the parent element is carbon. We distribute the sulfur around the carbon. So this is the third step. Step number 1, determine the magic number. Step number 2, determine the parent element. Step number 3, distribute the other element around the parent element. Now, step number 4, complete the octet of the other element. If any electrons remain, it should be placed on the central element. Now, let's take, for example, phosphine again, pH3. Now, let's calculate the available electron here. We have done that in step 1. The available electron in phosphine, phosphorus is in group 5. That will give me 5 electron. Plus hydrogen is in group 1. That is 1 electron. And we have 3 hydrogen. That will be what? 3 times 1 electron. Give me what? giving me 8 electrons. Now, let's step 2, we determine the parent element, which is what? Phosphine. Phosphine is the parent element. Step 3, distribute the other element around the phosphorus, the central element. Now, let's look at, now each of these bonds, each of these bond pair, they are 2 electrons. So we have 2 electron, 2 electron, 2 electrons. Since we have 3 bond pairs, we now have 6 electrons. Now, our available electron is 8. So we have used 6 electrons, remaining what? 2 electrons. The 2 electron remaining is a lone pair. It will be placed on the central element. So this is how to complete the octet of the element. Hydrogen obey duplex structure. So hydrogen can only take what? A maximum of 2 electrons. Now let's take another compound. Let's take BF3. Let's take BF3. Now, available electron, boron is in group 3. That will be 3 electron plus fluorine, not phosphorus, fluorine. Fluorine is in group 7. So we have 3 into 7 electrons. So what do we have? 3 times 7, 21 plus 3. That will give me 24 electrons. That's the electron available. Boron is the central element. So I will have boron, the central element. I will distribute the other elements around the central element. Now, apart from hydrogen and helium, every other element takes 8 electrons. Only hydrogen and helium that takes what? 2 electrons. Now, this fluorine atom has taken 2 electrons because this bond pair is 2 electrons. Now, 2 from 8 remaining 6. So this fluorine atom requires 6 electrons. So we have 1. That's 6 electrons. The same for the other fluorine atom. Now, so each of the fluorine atom takes what now? 8 electrons. 8, 8, 8. That gives us what? 24. So we have complete the octet of BF3. Now let's take one more example. Let's take water, for example. Water, available electron. Hydrogen will give me 1 electron. The 2 hydrogen will be 2 electrons plus oxygen, which is what? 6 electrons. So we now have total of what? 8 electrons. Now, it is oxygen. So distribute the order. We have 1 hydrogen here. We have what? 1 hydrogen. Each of the bond pair, this bond pair, 2 electrons, this other bond pair, 2 electrons. That making 4 electrons. From 8, we have 4 remaining electrons. And hydrogen obey only duplet structure. So hydrogen cannot take any electron again. The remaining 4 electrons goes on the central atom. So that will give me 2 electrons, making what? The 8 electrons. So this is how to determine the Lewis structure of a molecule. In our next class, we are going to deal with Lewis structure of various molecules and ions. Thank you.